Hello class, welcome to the next lesson in 8th grade Eureka Math. We're working in Module 4 and today we're working on Lesson 13 called the graph of a linear equation. Graph of a linear equation. So just like in the previous lessons, we're going to work on graphing, solving an equation and putting those solutions onto a graph. Today we're going to talk about what that graph looks like. What kind of shape can we expect from the graph of a linear equation? So you'll need graph paper, you'll need your writing tools, and you'll need pages 135 to 145 in your Module 4 workbook. And let's begin. Oh, as always, if I'm going too fast and you need to watch something again, you can go back and rewatch. If you need to pause the video and write something down, you are welcome to pause the video anytime. So pause, go back. Whatever you need, do your best to understand this lesson. Let's look at the vocabulary words first. We have 3 vocabulary words for this lesson: predict, rational numbers, and linear equation. So predict means to tell what will happen based on evidence. To tell what will happen based on evidence. So usually when we talk about predict in language arts, when we're trying to predict what might happen next in a short story, what might happen next. We can also predict in history what will happen next in the timeline sequence of events. We can also predict things in math. We can predict what will come next in the equation, what the equation will look like, what the graph might be. So today we're going to talk about predicting what the graph of a linear equation should be. Next term is rational numbers. Now rational numbers are all integers, that means whole numbers, all fractions, all repeating decimals, and all terminating or ending decimals, decimals with an end. Now that sounds like a lot, so you might be, if those are rational numbers, you might be asking, what's an irrational number? Well, an irrational number is like pi. You know, pi is 3.14159, 3.14159, and it keeps going and going and going and going. It never stops, and it's not predictable. It just keeps going, and it never repeats itself. Pi is one example of an irrational number. Today, when we're talking about linear equations, we're going to talk about rational numbers. So whole numbers, fractions, decimals that repeat, because those are predictable, and decimals that end. We're talking about all rational numbers today. Our last term we've seen before is linear equation. Linear equation is a statement for a relationship whose graph is a straight line. So in other lessons we've been seeing, when we're talking about rates and speed, we were saying how those relationships between speed and between distance and time are relationships, and we can use linear equations to show those relationships. So linear equations show relationships. But the special thing about linear equations is that they make a straight line. That's why you can see the word line inside of linear. So those are our 3 vocabulary words. Let's talk about what we're going to be doing today. Today, we will find solutions to linear equations, graph those solutions, and predict the shape of the graph for the whole equation. Because when we graph, we only graph part of the equation. We only graph what the values that we fix. We only graph what we choose to graph. You cannot graph the whole equation because the whole equation can go forever. So we're going to find some solutions to linear equations, graph those some solutions that we choose, and then we're going to predict the shape for all solutions, because we're only going to find some solutions. We don't find all of them. And because we only find some, we can only graph some. But we can predict the shape for all the solutions. And that's what we're doing today. And I do have an example for you. The example is on the next page. It's on graph paper, because if it's all about graphing, we're going to need graph paper. So I put our example on graph paper. Again, if you need to go back and add any details, if I talked a little bit too fast, you need to finish writing down your notes, do that right now. If you need to pause anytime, you can always pause. If you need to go back and rewatch, you can always rewatch. That's the great thing about these video lessons. You control the speed. Well, let's look at the example on the next page. Here it is. We're going to do our example is for the equation x plus y equals 6. And you can see that I have a great deal written down. Now, you can copy this down if you want. You are welcome to do that. If you want to pause the video and copy down whatever you can, that's fine. But you do not have to. You can just save a copy of, you can print a copy of this page. It's in the notes on the Google Classroom. Or you can just copy it at another time. But let's look at this. So what we're going to be doing today is we have a linear equation, x plus y equals 6. It's linear because the exponents are 1. The variable exponent's only 1. So that's linear, remember, all the way back to the beginning of the module. Linear means exponents of 1 or 0. And we have to find some solutions. So let's just start with the red fixed values for x. Now, I chose these red values. So let's solve them for these x. Well, if x is 0, 0 plus 6 equals 6. If x equals 1, 1 plus 5 equals 6. 2 plus 4 makes 6. 3 plus 3 makes 6. And 4 plus 2 makes 6. So those are all the solutions for our red solutions. Those are all the red solutions we have. When x is 0, y is 6. When x is 1, y has to be 5. X is 2, y has to be 4. X is 3, y has to be 3. X is 4, y has to be 2. Now we can graph these. So x is 0, y is 6. First one goes there. X is 1, y is 5. X is 2, y is 4. X is 3, y is 3. X is 4, y is 2. So you can see I graphed those solutions. Now, what kind of shape do you think that we're going to get for this graph? What kind of those are just the solutions those are just the values that we chose. What kind of shape could we get with this graph? Now, the tough part about this is you might think what shape we're going to see, but it's hard to be exactly sure at this point, because it is absolutely possible that what we see what we chose looks one way, but it changes. So, for example, it could do this. Right now, it looks like a line. It could make a line like that and keep going forever in a line. Or it could go for a line right here and then curve up and do something crazy, curve down and do something crazy. Or it could go like this. That's 3 different choices what it could be. Now, all 3 of those touch the 5 points we picked. All of our choices touch the red dots. How do we know which one is right? Is it squiggly? Is it zooming up and down like mountaintops? Or is it a straight line? We cannot really know at this point. So what we do to confirm, it's hard to, so right now it's hard to predict the shape of the whole graph because we only have part. We only have these 5 dots. It's difficult to make a prediction. So that's why we have some blue right here. We have some blue points because hopefully we can get some more evidence and see, have a better picture of what the graph will look like. So when x equals 1/2, y is going to be 5.5. 1.5, x is 4.5 for y. 2.5 for x is 3.5. 3.5 for x is 2.5. And 4.5 for x is 1.5. So now we have more evidence. Let's graph these blue points. 1/2 is going to be 5.5. 1.5 is going to be 4.5. 2.5 is going to, x is 3.5y. 3.5x is 2.5y. 4.5x is 1.5y. So now we have more evidence. We have the blue points, and it's looking more and more like this is actually a straight line. But can we be sure yet? Can we be sure? Well, you might be thinking, yes, I can be sure. But what happens if it changes at the negatives? What happens if in this quadrant it does something weird, and in this quadrant it does something weird? So let's add some more coordinates and see if it continues. When x is -1, -1 plus 7 makes 6. When x is -2, -2 plus 8 makes 6. When x is -3, -3 plus 9 makes 6. When x is 7, we do 7 and -1 makes 6. And when x is 8, 8 and -2 make 6. So now we have 5 more coordinates. So let's graph these ordered pairs to see what we get. So x is -1, y is 7. X is -2, y is 8. X is -3, y is 9. And then when x is 7, y is -1. And when x is 8, y is -2. Now it's looking closer and closer that it's going to be a straight line. So I'm actually just going to connect all these points right like this. And that is the shape of the graph. The shape of the graph is a straight line. Now, to know 100% for sure, we'd have to pick all the points in the world. We have to do this infinitely. But we cannot sit here and do infinite number of points to just confirm we're right. But this is enough evidence where we can know that the graph of a linear equation is a straight line. That's the big lesson for today. The graph of a linear equation is a straight line. And you can keep adding more and more points. Like we did 15 points on this table. We can keep going, add 20, 25, 30. We can keep going. But I'll tell you right now, no matter how many points you add, all the points are going to follow this orange line. And that's what we're going to do today. We're going to prove that today. In this example, I picked the coordinates and I found the shape of the line. In your work today, you are going to pick the coordinates and you're going to find the shapes of the lines. But this is the example. Let's do some exercises together where you can kind of work with me and we can experiment a little bit. So let's go to the first page of our lesson, page 135, and look at exercise 1. Exercise 1 says, find at least 10 solutions to the linear equation and plot the points on a coordinate plane. So find at least 10 solutions. So what I would like, so this is just like what we did in the last lesson. So you should know how to do this. You're going to find the solutions and graph them. So if you would like to right now, I would like you to pause the video and do this exercise on your own. I want you to pick your own x's because in our example, remember I chose what the x's were. For this exercise 1, you pick any x's you want, find the y's, and then graph them. So pick any x's you want, find the y's, and then graph them. And then resume the video when you're ready to check your work with mine. Okay, so hopefully you finished this chart for exercise 1. I'm going to do it right now. So when I have to pick x's, what I like to do is, 0 is always a pretty easy one. Then I'll just do 1, 2, 3, and 4. Now, just to keep it interesting and check everything else, the other thing that I like to do, I like to pick some negatives. So let's do 1, 2, 3, 4, and 5. and then I'll do -1, -2, -3, and -4. So I have positive x's and negative x's. You can pick, you should have picked whatever you wanted. So maybe you picked some fractions. That's perfectly good. Maybe you picked some bigger numbers. That's fine too. You could do whatever you want for this. Now, after you picked your x's, we need to solve. So 3x plus y is 3 times 0 plus y equals -8. We get 0 plus y equals -8. So y is going to be -8. For x is 1, we get 3 times 1 plus y equals -8. That's 3 plus y equals -8. And remember, subtraction property of equality, take it away from both sides, we find out that y equals -11. 2, we get 3 times 2 plus y equals -8. That's 6 plus y equals -8. Do -6 from both sides, subtraction property of equality. When x is 2, y is going to be -14. 3, we got 3 times 3 plus y equals -8. That's 9 plus y equals -8. This time we take 9 away from both sides and we get -17. Next x, we do 3 times 4 plus y equals -8. That's 12 plus y equals -8. Subtraction property of equality, y is going to be -20. Or when x is 5, 3 times 5 plus y, we get 15 plus y equals -8. Sorry, that's regular 15. 15 plus y equals -8. Subtraction property of equality tells us that this time x is -23. Now let's find my negative coordinates. We get 3 times -1 plus y equals -8. That's -3 plus y equals -8. And this time I have to do the addition property of equality, add 3 to both sides. So this time y is -5. For -2, 3 times -2 plus y equals -8. That's -6 plus y equals -8. Add 6 to both sides. Y is going to be -2. And this is all work that we've been practicing all of Module 4. So you should be doing this just as quick as me. X is -3. So we do 3 times -3 plus y equals -8. That's -9 plus y equals -8. Addition property of equality to get the 9 to make the 9 turn into a 0. We do it to both sides. So this time -8 plus 9, y is going to be 1. Now we have 3 times -4 plus y equals -8. That's -12 plus y equals -8. So we add 12 to both sides, and this time y is going to be 4. So those are the coordinates that I got. Let me turn my coordinates into a list of ordered pairs. So we have 0 and -8, 1 and -11, 2 and -14, 3 and -17, 4 and -20, 5 and -23, -1 and -5, -2 and -2, -3 and 1, -4 and 4. There we go. So we got all this stuff right here. We got our list of ordered pairs. Now I am ready to graph these ordered pairs. So let me grab some of my graph paper. And you probably got different ordered pairs than me when you did your work, but that's okay. In fact, I hope you got some different numbers than me so that we can compare this a little bit better. So for exercise 1, let me label this exercises. Exercise 1, I'm going to need a graph. Now, looking at my ordered pairs, my x's go from -4 up to 5. x's go from -4 to 5. So, but my y's go from -23 up to 4. So I'm going to be super negative. I need lots of room on my negatives. So I'm actually going to go right here. X's go up to -4, so that'll work. Let's see. Let's go there. Okay, so then I'm going to go down here. This is my y. This is my x. Now my y is 1, 2, 3, 4, which will work because my biggest y is a 4, so it will be on the chart. My x's, here's the 0, so I have 1, 2, 3, 4, 5, 6 on the x's, which works because my biggest x is 5. My negative x's go up to -6, which works because my smallest x is -4s, so it will fit. But my y's need to go down to -23, which means I need to go down 23 spaces. So I just drew a big line down. Let me label these. -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12, -13, -14, -15, -16, -17, -18, -19, -20. I need to go down to -23, so I need to add some more. -21, -22, -23, and that's where I'll stop. So there's my graph. All of my x's are on the axis. All of my y's are on the axis. So I have plenty of room to graph my points. So let's graph my points. I have 0 and -8. So 0x, -8y goes right there. 1 and -11. 1 on the x, -11 on the y right there. 2, comma, -14. 2 on the x, and I go down to -14. 3 and -17. 3 on the x, -17 on the y. 4 and -20. Here's the 4. I go all the way down, and I put it at -20. 5 and -23. So I find 5 on the x, and I go down to -23 on the y. So those are 5 coordinates. Let's go to the next one. -1 and -5. So -1 on the x, -5 on the y. -2 on the x, -2 on the y. Right there, 2x, -2x, -2y, that's where they meet. -3 on the x, 1 on the y. -3 on the x, go up to 1 on the y. -4x and 4y, so go up -4 on the x and go up to 4y. So those are my coordinates. You can see right there, all the blue dots are the ones that I got. Now, like I said, you might have gotten different points than me. If you picked different x's, you got different dots. But one thing I know is that whatever x's you picked, they are going to be somewhere on this line. Because if I connect all my points, I make a line. You can see all the way up to my top point, all the way down to the last point I came up with, all connected on that line. And any points that you made when you did it on yourself, when you did it by yourself, you got points on the same line. So that's what we're doing today. So we both should have made the same line. This is the red line is the graph for the equation. So whatever x's and y's we pick, whatever x's and y's you pick for your table will always be on this line because that is the line for the graph. So at the bottom of exercise 1, what shape is the graph of the linear equation taking? It is a straight line. Linear equations make straight lines. Let's go to page 136. It's going to ask us to do the same thing again. Same thing again. Now, I'm just going to skip it because I'm just going to tell you right here that we just spent some time and we did exercise 1. If you want to watch us do exercise 1 again, you can. If you want to contact me for a meeting and you say, Mr. Baylor, can you do exercise 2 with me? I will do exercise 2 with you. But exercise 2 is exactly the same as exercise 1. And in fact, if you pick X's, like if I'm picking, I'm actually going to pick Y's first because remember this is the Y has the more complicated coefficient. So I would do like 0, 1, 2, 3, 4, and I do -1, -2, -3, -4, and then maybe -5. That's you could pick that. But you can pick something completely different. Maybe you want to try doing this with fractions. That is perfectly good. But I'm going to tell you right now, the shape that you're going to take is still going to be a straight line. It will be a straight line every time because it's a linear equation. And even if you pick something different, let's say you pick fractions, like you do 1/5, 2/5, 3/5, 4/5, -1/5, -2/5, -3/5, -4/5, and -5/5, which equals -1. You can pick different ones and you will always get the same straight line. Whatever you pick, you are going to make the same straight line. And that's what you're practicing today. You're practicing you're practicing several skills with this. First thing, you're practicing solving the equation to find X and Y. You solve the equation to find X and Y. That's the first skill you're practicing. Skill number 2 is you're practicing graphing. You're practicing making your ordered pairs, and you're practicing making a graph. The third skill that you're practicing is understanding that linear equations make straight lines. So you're really practicing, you're really getting 3 skills today in just 1 lesson. We're also not going to really talk about page 137. I mean, number 3 and 4, you're supposed to compare with a partner. You can do that if you want, but I promise you that if you and your partner do it correctly, you're going to see the same line. Even if you pick different points, if you and your partner found the correct solutions, you're going to see the straight line. So this shape of the graph will still be the same. Number 5, Joey predicts that the graph of this equation will look like this. Do you agree with Joey? Well, I'm going to say no because this is a linear equation, but Joey does not have a linear equation line. In fact, Joey has a point down here. All Joey's other points are right here. So I'm going to guess that when Joey was trying to do this, he made a mistake with this point. This point should be right here to keep the line going. So I'm going to say I disagree with Joey because this is a linear equation, but his graph is not a straight line. So -x plus 2y equals 3 is a linear equation, but Joey did not graph a straight line. And that's the big takeaway today. Linear equations always make straight lines. Linear equations always make straight lines. Number 6 on your exercises is asking, can you write an equation with solutions that does not form a line? Well, think about it. Think about the beginning of Module 4 when we talked about linear equations. Now remember, a linear equation needs an exponent that is 1 or 0. So what kind of equation will not be a straight line? Well, you need not a linear equation. So if you have something like x squared plus y equals 5, this is not a straight line because it is not linear. And how do you prove it's not linear? That exponent right there is a 2. It has to be a 1 or a 0 to be linear. Has to be a 1 or a 0 to make a straight line. But test it yourself. Change the exponent, make a list on a table, and try it. But really, today's work is just graphing linear equations and seeing what the graphs look like. So you're practicing your solving skills, practicing your graphing skills, and you're predicting and observing. Let's look at the work you're going to do today. Here's the lesson summary. But we already talked about just together, so we're fine with that. Here's the exit ticket you'll do last, so I'll slide that to the back. Here is the homework helper on page 141 and 142. If you need a little bit more help with this, if you need a little bit more guidance, they did the table and the solutions for you. They did the graph for you, so you can choose, so you can read all of these to get a little bit more guidance about how to solve and how to graph. For the problem set, after you've looked at the notes and you feel comfortable doing all this, it's time for the problem set. Number 1, find at least 10 solutions to this linear equation and plot the points on a coordinate plane. What shape is the graph of the linear equation taking? So for number 1, you need 10 solutions. So you need to build a table. And then you're going to plot the points, which means you're going to graph. And then what shape is the graph? Tell me what shape is the graph. So I need to see the table, I need to see your graph, and I need you to tell me the shape. Now remember, when you're making your table for this, start with the x's and make your x's easy because the coefficient is 1/2. And in lesson 12, we talked about how you can choose x's that make the coefficient easier for you. For number 2 on the problem set, do these points right here, does it look like these points, could the following points be on the graph? So do these points make sense on this equation? Yes or no, and remember to explain why. So do all these points make sense for this? Or is there something wrong? For number 3, can these points, and you might be a little bit hard to see what points they're talking about, but can these points be on that equation? Can the following points be on that equation, or is there something wrong? Explain. Problem set continues on page 144, asking the same question. Can these points, do these points match this equation? So so it's asking you a lot. Does the graph match the equation? So for number 2, does the graph match the equation? For number 3, does the graph match the equation? For number 4, does the graph match the equation? And for number 5, does the graph match the equation? Do the graphs match the equation? You tell me. And then for number 6, again, do the points on the graph match the equation? And number 7, does the graph match the equation? Tell me why or why not. And then after you do all that, remember my answers to the problem set are posted on the Google Classroom so you can check your work with mine. When you check your answers and you feel confident, you feel like you know what you're doing, then work on the exit ticket from page 139. Page 139 exit ticket has 2 questions. It talks about Ethan finding solutions and graph them. It's just asking you for this one, what shape is Ethan's graph? What shape is Ethan's graph? And then for number 2, it's asking again, do the points match the graph? Does the graph match the equation? Does graph match equation? That's what it's asking. Did this person do it right, or did they make a mistake? You tell me. But that's your exit ticket today. Remember to try the problem set, check your problem set answers with mine, ask me if you need any help, and then work on the exit ticket. Take a picture of your exit ticket and turn it into the Google Classroom when you're done. But work hard, have some fun with it, and I will see you for the next lesson.